Hi gents, we're going to have a quick little look here at trigonometry, just another one of our topics that we're going to revise out. So this here is taken from the 6th year mock that some of the students would have done. And it's just a way just to sort of get yourself back into it and go from there. Okay. So it says television mast is held in a vertical position by two metal supports, AE, which is shown there maybe. In fact, it's not AE. So I wonder, was that I think that might have just been I think that might have meant AD. This looks like a support to me, but I could be wrong. And CE, maybe that's what they meant. And a wire cable AF. Yeah, well, that looks like a wire cable AF as shown. Okay, so I think that was just a small little mistake that they had. Yeah, because it says A to D there is 2.4, so obviously a small little typo. AF is 3.7 meters, DF, that's important, D to F, that's just from there to there is 1.8, okay. CE is 2.9 and BCE is that. Okay, first things first, find BE. So I'd be saying to myself, what type of triangle is BE in? And I would notice that it's in this, which is a right angle triangle. We want to get the opposite, and we have the hypotenuse. So opposite and hypotenuse, that's sine. It's just a right angle triangle, it's just sine cos tan. Sine equals opposite over hypotenuse. The opposite, we'll call it x, or BE we'll call it, sure, why not? So BE over the hypotenuse, which is 2.9. So we had 2.9 times the sine of the angle, and the angle that we were talking about was 48. Okay, so 2.9 sine 48 is equal to BE. So now if we can just find a calculator, which as per usual I don't have to hand, we can go from there. So 2.9 sine 48, and we are in degrees mode, so that's fine. So this says to me here that BE to two decimal places is 2.155, so 2.16, and those are meters. Okay, so we now know that's 2.16. Okay, find angle A to D to F. So A to D to F means find this angle in there. We'll get rid of that. A to D to F, the 2.16 is just from there to there. So find this angle here. So again, I say to myself, what type of triangle is this part of? Okay, what type of triangle is this part of? And it is part of a non-right angle triangle. Okay, it's a non-right angle triangle. And we have three sides, 1, 2, 3 sides of a non-right angle triangle. Whenever I see three sides and we need the angle, we should be using the cosine rule. So the cosine rule goes a squared equals b squared plus c squared minus 2bc cos a. So we're talking about cos a or cos theta. So the a that we're talking about here has to be the side which is opposite it. So that's 3.7 squared is equal to, and here it doesn't matter which one you put first, 2.4 squared plus 1.8 squared minus 2 times 2.4 times 1.8. Okay, so what's going to happen here? We're going to have 3.7 squared minus 2.4 squared minus 1.8 squared. So on the left hand side, 4.69, that's what I'm getting, is equal to minus, and this is going to be 2.4 times 2 times 1.8. That comes out as minus 8.64. Just going to double check something. 317 squared, 13.69. 13.69. This thing won't get out of it. That's 9. Okay, yeah, that is, that's all good, and it's cos theta. So we get that cos theta is equal to 4.69 over minus 8.64. So theta is equal to cos inverse of that thing there. I'll just say ANS. Okay, so 4.69 divided by minus 8.64. Okay, so if I now do cos inverse of the answer, cos inverse ANS press equals, it's telling me that theta there is 122. Said to the nearest degree 0.8, so 123 degrees. There's my answer. Okay, I did spot, I didn't want to give it away there because it's important that you know when to use the cosine rule, but I did see a cheeky way of getting it. If we had looked at this angle here, gamma and theta make up 180 degrees. So actually, if you just looked at gamma, which is part of a nice, easy right angle triangle where we know that this is 2.16, we know that this is 2.4, okay, and we're trying to get gamma. We know this is the opposite, this is the hypotenuse, and this is the adjacent. We know that adjacent and hypotenuse, we're dealing with cos. So we could have said cos gamma is equal to adjacent, 2.16, over hypotenuse, which is 2.4, and if we get cos inverse of that, 2.16 divided by 2.4, so I'm just on an old calculator, 0.9. So cos theta is equal to 0.9. So if we do cos inverse of the answer, it turns out that we get 26 degrees. And if you do 180 minus 26, 180 minus 26, you do end up with 154, which is totally different to the answer that we got there. Have I done anything stupid? Let me just think about that. It is adjacent and it is hypotenuse. It is 2.16 and it is 2.4. Yeah, so it is. Maybe I mistyped something. 2.16 divided by 2.4 is that. And if I do cos inverse answer, I do end up with 26 degrees. That is what I'm getting. And that is a straight angle. Yeah, so if I do 180 minus 26, I am going to get 154. So let me just double check the numbers that I've used down here first. 3.7, 2.4, 1.8. Okay, 3.7 squared minus 2.4 squared minus 1.8 squared. Yeah, so this number is right. 2 times 2.4 times 1.8. That is also correct. Lovely. So 4.69 divided by 8.64 is that, times minus 1. Okay, and if I then do it is the cosine rule, so if I do cos inverse of the answer, I am going to get 123 degrees. I wonder, this could be bad news now for this. Let me just see where I managed to pluck this thing from here. I wonder, did they make a mistake? Was it a case that they had an impossible triangle on it? It's happened in the leaving cert, but you really don't want that to happen. You just create conditions where an impossible triangle exists. Let me see, we must be pretty close to it. Which question was it? Did it say question 9? Sorry, we're on 5. So much for being close to it. 7, 8. Question 9, 2.16, so we didn't get that one wrong. And we get 123 degrees there, which is the answer, but it does cause an issue. Let me just make sure that I haven't done anything silly on the other side. 2.16 was that. What was that? That was BE. No, disaster. Look at that. Sorry, 2.16 was going the whole way up there. Okay, it wasn't up to BD. It doesn't help that they have mislabeled that. So sorry. Forget that lovely little thing that I had there. We don't know that that's 2.16. Of course, we don't know that. So what we have now is we would have had this, but nothing else to go on. Okay, so we can't do that. And actually, I wonder, is this going to be important in a second? It asks us to find EF. Just EF from there to there. So actually, what are we going to be able to do? If we look at the slightly bigger triangle, we might be able to figure this section out here. Okay, hence means using what you've just done. Go and get out what the answer is there. So once just EF, if we have a little look at that, let's come up with some plans. We now famously know that this thing here from there to there, that's the whole thing there is 2.16. 2.16. So if we can go and get what is BF, okay, if we can go and get what BF is, we can take 2.16 away from it. Also, if you go and get what is DF, is that going to be helpful? It will be if you happen to know this length here. But I think what we should be probably trying to do is we should be probably trying to get what's BF. Okay, I tell you what I'm going to do. I'm just going to pause it here. Maybe I can try to edit out that little bit, and I'll come back to you. Okay, I've tried. I'm not going to be able to get rid of that little bit just where I thought it was 2.16 just up to D. But you know what? It does lead us to the right answer here in terms of what we were going to do. So that was 1, 2, 3. So actually it's the same plan. So if it was 180 minus 1, 2, 3, we would see that this is 57, which it is. So what we're going to be able to do now is we're going to be able to work out what is this length here. Okay, what is from D to B. Okay, if you look at this right angle triangle, this is 2.4, this is 57, and this is X. So it's much like what we've gone and done before. It still costs. The cos of 57 is equal to the adjacent over the hypotenuse. So X is just 2.4 cos 57. So 2.4 cos 57. X is equal to, we'll do it to one decimal place, or 2 decimal places, 1.31. Okay, so now if we just have a quick little think about this, what do we have? What we now know is we now know the whole thing. We know that the whole thing is made up of 1.31 to get to there and a further 1.8. So to go from B all the way to F, it's just going to be 1.31 plus 1.8. So the length of the whole mast is 3.11. Okay, that's 1.31 plus 1.8. And we know from before that from there to there is 2.16. Okay, so obviously the bit that's left over, okay, if it goes 3.11, you just have to take away 2.16 and see that this bit is 0.95. Okay, that bit is 0.95. So correct, get EF to that. So it's 3.11 minus 2.16 is equal to 0.95 meters. So that's the little plan that you would come up with, and we can just double check just to see what this says there. It says at 0.95 meters. Okay, so this question here, what did you have to do? You had to first of all use just right angle triangle, sine, cos, tan. Nice and simple. Next thing that you had to do is you had to see that there were 3 sides and you needed to get the angle, which turns out to be 1, 2, 3. And the only way to do that is the cosine rule. Okay, the reason that you can't use the sine rule, just since we're doing a bit of revision here. 3.7, 2.4, 1.8. You know, if you're trying to do the sine rule, sine A over A equals sine B over B. You know, you'll say sine A or sine theta over the side opposite it, which is 3.7, is equal to the sine of, oh, well, we don't know any other angle. So you're going to have two unknowns inside the question. So inside the equation, so you won't be able to solve it. So cosine rule is what you want to do when you have all three sides. This is for a non-right angle triangle. All three sides, cosine rule, or two sides and the included angle, that is, say, the angle in between. Included angle. Okay. Otherwise, you're going to use the sine rule, and if it's a right angle triangle, sine, cos, tan, or Pythagoras' theorem. Okay. So yeah, so for that one we had to use cosine rule, and then for this one, really, what you're just back to doing is you're just back to doing a little bit of right angle triangle stuff here in order to get that BD from there to there. We were able to get that was 1.31. We added it all together, got the height of the mast, and took away the 2.16 and got it there. So there's a little bit of planning, I guess, involved in it as well. So that's just a little reminder of trigonometry, just something to try out, just to see if you are able to remember it. Okay, gents, all the best. Take care.